Okay, welcome to the Project 2 tutorial. So I'm going to cover all of the basic Verilog concepts that you will need to know in order to accomplish Project 2. So in this example, I'm going to be taking in two 16-bit numbers. I'm going to call them A and B. We're going to add them together, so we're going to call that sum, and account for overflow. So these are all going to be variables that we're going to be placing into our code. OF for overflow, and we'll replace that value sum with x's, raising an overflow flag. So there's our OF. After the addition, we will invert the result. So we're going to call that variable flip. And we are also going to raise an alarm flag on certain values. So we're going to call that alarm. And I just chose 1 and 3. So to get started, we've got our fresh empty module here. So we're going to go ahead and declare our inputs and outputs right here. So we've got our input A, our input B, our output sum, output flip, and OF for overflow, and alarm. So I'll close that off, semicolon. Now, for our inputs, we are taking in two 16-bit numbers. Now, doing this with wires would take up quite a lot of code and a lot of time, so we're going to do this all at once by creating a bus. Now, these are what they sound like. It's basically like a bunch of wires lined up next to each other, all firing at the same time, so you can get more than 1-bit values. So we're going to type that in. We'll start off by saying input, and then you do a left square brace, and then you start with your most significant bit, 15, to the least, to 0. Alright, and we are going to name this A. So we will also do this for B. So input 15 on most significant to least significant B. Now the reason that we don't say 16 0 is because 0 counts as a number. So you could do 16 to 1, but it is a better practice to start from bit 0. Now, we are going to set up our flags. So we have our overflow and our alarm. So for this, these are going to be output reg, means register. So this means that it will be, this register means that it will be stored somewhere so we can see it on a timing diagram. And especially if there's something going on in the middle of your circuit that isn't a specific output of your entire program, but rather just some intermediary step, then you can say output register, and you'll be able to, like I said, see it on your timing diagram, so it can help you trace how your data is flowing through the circuit. So we want to name our variables, alarm and OF. Since these are both only 1 bit, we can go ahead and name a couple of them at once. So now we'll go ahead and set up our output for our result of A plus B. So once again, it's going to be 16 bits wide, and we're going to call that sum. And we will do the same thing with our inverting register. Now we don't necessarily have to have a separate variable, but it is nice to see sum and flip right next to each other, so that way you can really see that the flip is actually doing some kind of post-processing on this variable sum, which is one of the things that we're asking you to do. So when writing behavioral Verilog such as this, we will be working a lot with always blocks. So we'll start off by typing always at, and then a left parenthesis, and then you will state your input parameters here. Now, it doesn't necessarily have to be an input, but it has to be some kind of value that changes or is active somehow. So we're going to start this off with our inputs A, comma, B. And you say begin. So what this is saying is that whenever A or B are active, every time, that's where the always comes into play, then we will execute this code below that we're about to type. Now don't forget to terminate every begin with an end. Because you get some errors and won't compile, and yeah, so do that early, because sometimes you'll forget and it can really be a pain. So for addition, we can account for our overflow within Verilog with a operator that they have built in. So for addition, we do a left curly brace and start with our overflow variable, and then our sum, right curly brace, equals A plus B, and then semicolon. So what this little curly brace does is it will add the two numbers, and if there is a carry, then that will be represented here in the overflow. In this case, carry means overflow, so that means that value is outside of the range that we've given, so you can't do anything with it. So now we have the first part of our program. So we are adding A and B together, and the result is being output to sum, and if there's a carry, that will be noted with overflow. So now we are going to do some post-processing on that sum. So we're going to start another always block. So always at, and this time our input parameter is going to be sum. Again, go ahead and put the end in there. So now for part 2. We will cover the overflow soon. So after the addition, we will want to invert the results and raise a alarm on values 1 and 3. So let's start off with initializing our alarm variable. So alarm equals 0. Now, what I'm going to show you is called a case statement, much like Java or any other, or C or any other programming language that you might have used before. So the syntax for this is case, and then you say what the input of your case is, which is sum. So now we are going to say when sum equals a certain value, in this case 16 would be, I don't know if you've seen me do this before, but this 16 apostrophe B means we have 16 bits and we are representing it in binary. Like if I said 16H, that would be hexadecimal, or I think I is integer, or D for decimal. I don't remember. I don't really use those. But anyways, so our 16-bit binary number, we wanted to raise that flag on 1 and 3. So let's do 1. Oops. So there's 1. So what we're saying here is when sum equals 1, and then you put a colon here. It's basically like an if-then statement. So this is like saying if sum equals 1, then we will raise our alarm flag. Alarm equals 1. And the other case where that was true was when results equaled 3. So we'll say 16 B. There's 3. Then alarm equals 1. And then we will terminate this statement by saying end case. So now we're going to go ahead and perform the action on every instance of sum, which will be to invert. So we'll say here flip, which is the variable that we're using to store the inverted sum, equals tilde sum. Now the tilde key means not, so it will invert whatever is after it. So it's a negation. And now we will account for our overflow. So we'll say if OF equals 1, begin. So this is kind of like the case statement, but it's all we only have one option, so we might as well just do the if. And we will say sum equals 16bx. So, whoops. So this means that if I have an overflow, then my result will just be a bunch of x's. So then we'll want to end this if. And it looks like we ended this sum. So let's save. Make sure we got everything all right here. Oh my. Okay. So I already went ahead and wrote out a test bench. Make sure I have everything named the same. Ooh, alarm. Okay. Get that saved. Check our syntax. Alright. So in the test bench here, I've tested out a couple more options. I put the monitor in here so we can see what's happening. I'm sure you guys are familiar with how this is constructed already, so I'm not going to go over that. So we start off with 0, 0 to initialize our inputs, so pause for 100 milliseconds, and then we have A equal 1 and B equals 0, which will raise our first alarm flag, or should at least. And then we have an addition of 20 and 10, which will just be a regular addition with the results getting flipped. And then here we have the addition of 2 and 1, so 3, so this will raise our next flag notation. So this is the same as doing 16 ones. So this will raise our overflow flag and hopefully get us those red X's in our results. And then this is just another standard addition. So let's check it out. Alright, so here we have it. Let's go ahead and zoom out. So, as we can see, when our result is 1 down here and over here, we see that our alarm is triggered. That was from that case statement. Now this can be applied pretty directly somewhere in your project. I don't want to be a complete giveaway, so it's about as much as I can say, but yeah. So here we have our just generic computation. Another alarm raised right here. So when our overflow flag is raised, we had all ones and then tried to add a couple more. Just put X's in there. That flipped is yeah, something pretty crazy. But our overflow is 1. I suppose we could have made flip X as well, because this is a garbage value. But this is just an example. So then our next standard computation right here. Looks good. So yeah, hopefully this was helpful to you guys. If you have any questions, keep asking on the forum. I'm trying to keep up as best I can. And good luck.